Alright, so we're looking at the closure activity that we did today. We went through the 9 main concepts that are going to be on your Chapter 6 test. And so we're going to go over the solutions for these. And so the first one we're really looking at is dealing with vectors. And so we're kind of being asked here to be creating the component form of a vector. And this one deals with vector operations, 2a minus 3c, where a and c are vectors, and they're defined by the component form you can see down below. Then you're asked to graph it, and the reason why we're asking you to graph it is so you can better find not the magnitude, that should make sense for the most part when it comes to Pythagorean theorem, but for the direction. By graphing it, we'll see what quadrant we're in, and we can figure out how we're going to find the direction. So first off, let's look at the different ways we're going to do this. So if I have twice vector A, and I'm going to do this vertically so we can kind of see what's going on. If I'm dealing with twice A, and so if I do this, I'm going to get 8, because 2 times 4, and then 2 times negative 7, negative 14. And then that's minus, we do minus, 3 times vector C. So 3 times vector C. Well, 3 times vector C, 3 times 6 is 18. 3 times negative 3 is negative 9. And if I just think about it, I want to know what that equals. So 8 minus 18 is negative 10. Negative 14 minus negative 9 is going to be a negative 5. And so that takes care of the first thing, the component form. Now I did this vertically because it allowed me to kind of see what was going on side by side. Now if I were to deal with this horizontally, there is a very good chance that I would think of it as a negative 3 being distributed. And so I'll take care of this in, we'll say yellow. So if I do twice A, it doesn't really change anything, 8 negative 14. But if I think of this as a negative 3, and I distribute it as a negative 3, which would be negative 18, positive 9, then I have to change that to a plus sign. And that would give me the same general setup that we had for the other ones, because 8 plus negative 18 is negative 10, negative 14, plus 9 is negative 5. So either one of these works, and that takes care of our component form. That's the first thing we're being asked to do. The next thing we're being asked to do is to graph. And so I'm going to graph negative 10, negative 5. So let's draw our x, y axes. So that would be the third quadrant, so I'm going to focus there. I don't have it labeled, so let's label it. This would be negative 10. That makes sense. This would be negative 5. That makes sense. And I'm going to plot a point. Third quadrant, boom, boom. There is my vector. Perfect. There, it's graphed. So that takes care of the second one. Now the next thing says, hey, find the magnitude. Now the reason why I graphed it is because then I can draw in my right triangle. And I'll just slide the negative 10 over here, and I'll slide the negative 5 over here so I can see it as a right triangle with the dimensions. If I want to find the magnitude, it says, well, the magnitude is just going to be the length of your vector, which is in Pythagorean theorem. So my magnitude equals the square root of negative 10 squared plus negative 5 squared. And in that case, we have the magnitude equals the square root of 125, which is approximately 11.2. And so we can look at that. There's our magnitude. What else do we have left? It says find the magnitude and the direction. Direction, let's do green and change up the colors a little bit. So we're looking at this, and I want to find the direction. Well, first thing I need to know is what's theta? What's the angle inside the triangle? And so I'm going to say, hey, I know my opposite, and I know my adjacent, so I'm going to do the inverse tangent of my opposite over adjacent. And yes, I'm just going to write 5 tenths instead of negative 5 or negative 10, because come on, really a negative divided by negative? And if I do that in my calculator, I'm going to get around 26.6 degrees, and that is not my direction. Because the 26.6 degrees, that is the angle inside this reference triangle of the vector. I need to still add 180 degrees to it to get the direction in standard form. So to do my direction, I have to do 180 degrees plus the 26.6 degrees. And so my direction is 206.6 degrees. And that's your answers. And I do say the plural, answers, because there were 4 things we were asked to do for this problem. We were asked to find the component form of the operation, 2 times vector A minus 3 times vector C, done in the lower left. We were asked to find the graph of it. We did that in yellow. The reason why we graph it is to help us with our magnitude. and our direction, primarily the direction, because then we know what quadrant we're in. And if I'm in the third quadrant, it's between 180 to 270 degrees. And I do have an answer in there. So that's the first concept that's on your Chapter 6 test. The next one is solving trig equations. And I say this because we need to understand what this means. If I'm trying to solve a trig equation here, I'm trying to find, in this case, what is theta? What is the value of theta? What does theta represent? Well, we just did a problem that had theta, and that theta represented angles. So when I say solve the following equation, in this case, theta for this first one, and for the second one, in this case, that x variable, those represent angles. You may be going through your mind, okay, so I'm dealing with angles, so probably degrees, right? And in this case, it's not written here, but it is written on your closure. It's written on the test. It's written on your review previews. They usually have this direction, 0 less than or equal to, and I'll just use x, less than 2 pi. That statement there has a couple of things. One, it tells you one rotation around the unit circle, 0 to 2 pi. But primarily, what you need to realize from it is it tells you that you are dealing with radians, because you have 0 to 2 pi. Those are radian angle measures. So keep that in mind. And I say that because I need to know I'm trying to find angles. I'm not finding the coordinates. I'm going to use the coordinates to help me find the angles. So in this case, if I do the first one, as do green, I'm going to subtract 1. And really, I'm going to divide by 2. And that's going to isolate my cosine of theta. I would subtract 1, have 2 cosine of theta equals -1, divide by 2. Perfect. Well, what does this mean? This means if I have cosine of theta equals -1/2, that means I have a negative x value, because cosines are x values around the unit circle. So I have a negative x value of, well, I have -1/2. So if I have an x value -1/2, but boom, here's -1/2. What coordinates around the unit circle correspond to those x values? And that would be this point right here and this point right here. Well, then those coordinates must be my answer. Well, no, I'm telling you that's the point that corresponds to it. The problem is asking us to find the angles that correspond to it. So I want to know, what is this angle in radians? Well, that angle in radians is going to be pi thirds, but what's the coefficient? Well, in this case, it's 2 pi thirds, because this is pi thirds right here, and this is 2 pi thirds. And so I have to keep in mind I'm looking at bigger slices, so thirds are some of the bigger slices we're dealing with. All right, so that has to be the only one. No, I did. I marked that one down in the third quadrant too, so it's also this angle right here. What does that mean? It's 3 pi thirds? No, because 3 pi thirds is pi. It's a whole pi. So what is the next one? Well, it's going to be 4 pi thirds. So when you have the big slices, and you have to realize I was really trying to find what is this angle measure now for that one. So I'm not looking for the coordinate. I'm using the coordinates to find those angles. Now, what's the next one? Because we have another slide, so I'm just going to do this to make my life a little bit easier. I'm going to leave the pi there just to be helpful. 2 sine of x minus square root of 3 equals 0. Well, what's the first thing I'm going to do? Let's use yellow. I'm going to add the square root of 3. That would at least isolate the sine of x, wouldn't it? And then, well, I'd end up dividing by 2 for this one. So divided by 2. So the sine of x equals square root of 3 over 2. What does that mean? Well, sines mean y values around the unit circle. So really, I'm trying to find all the positive y values around the unit circle that have a value of radical 3 over 2. Well, wait a minute. Radical 3 over 2. Radical 3 over 2. Big, small, compared to 1/2. Well, it's bigger than 1/2. So radical 3 over 2 would be, closer to the outside of the circle. And that'd be this point and this point. Well, those points, nope, that's not my answer. The angles that correspond to those points, that's my answer. So I want to know what's this angle measure from here to here. And in that case, it is going to be, we'll stick with orange, and up, this is x. So I'm going to say x equals pi thirds. All right, well, the next one, well, that's right here. Well, we already found that in the other one. This angle from here to here, we said in the previous one, is 2 pi thirds. Now, this doesn't mean every single angle you deal with is going to be pi thirds. We have to keep in mind what are the different angles. And so, you know what? Just to be generous, because who knows why I'm saying this in the video. But what are the other angles? Well, they could be anything that's closer to the x-axis. None of our examples dealt with that. What are those? Closer to the x-axis is going to be something pi 6. And then you have 5 pi 6. And then you have 7 pi 6. And you have 11 pi 6. If they're around there, you have it. Now, pi 6, they still deal with the positive negative 1/2 or positive negative radical 3/2. So when you have those, you have to realize, am I dealing with thirds or sixths? Now, the next one that we can look at when it comes to the unit circle is figuring out what's the last one that we did not do. And the last one we didn't do is we didn't split the quadrants perfectly in half. I did not split the first and third quadrant perfectly in half. I did not split this quadrant perfectly in half. What are those angles? Well, those angles are something pi fourths. And so I need to figure out, okay, what are the coordinates for something pi fourths? And those are positive negative radical 2/2. So if I were to have that, I'd be dealing with something pi fourths. Either pi fourths, I have 3 pi fourths, 5 pi fourths, or 7 pi fourths. So use this unit circle to kind of help you out with what you're dealing with on those. All right, the next one. Ooh, what are these? Well, 3 to the 2x plus 4 equals 243 to the 5 minus 2x. Yuck. 170 equals 12 to the x minus 8 minus 130. Notice how I have variables in all of those exponents. So when I have variables in the exponents, I call those exponential. I'm just going to do this, exponential equations. When you have exponential equations, there are two different ways of solving. You have either creating a common base, welcome to this first problem, or you have using logs, welcome to the second problem. And that's the general setup. When we talked about this in class is the structure itself can help you figure it out. Do you notice the differences between them? If you look at the first problem, you have a base to a power equals a base to a power. Usually when that happens, not always, but when I see that, I think that it's going to be a common base problem here. And the reason why is because there's only a base equals a base to a power and a power, so something tells me on that I'm going to create common bases. If I look at this one, how do I kind of see this on a test and go, I'm probably thinking logs if I have a variable in the exponent there. Because it has a plus or minus sign after the base. It could have a coefficient to the base. And when that happens, it's very rare to be able to create a common logarithm. Sorry, to create a common base. And so I'm going to have to use logs. So the more complicated the problem looks, the more likely I'm probably going to use logarithms. The more I say basic, structurally basic the problem looks, I'm probably going to use a common base. This one's a common base. Now, and a common base means you need to get the bases to be the same. And we are going to look at two different ways. We're going to look at a green way, we're going to look at a blue way. A yellow way. One of those is right, one of those is wrong. And the idea is to create a common base. And so you have two students, and both students have a general understanding of how to use common bases. It's just they kind of mess up some of the things. And the idea is you can realize, hey, 243 is 3 to the 5th power, which by the way it is. That's right. But I still have this 5 minus 2x here. Okay? And then they go, well, you know what? I have 243, correct? That's what I dealt with on the one side. So, okay, well, I need 243 because I need a common base. And they do this. Boom, 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 2x plus 4. And they would cross out and solve. That's student A. Student B, when we're looking at this, they do something a little bit different. A little bit different. They still go, you know what? I'm going to agree with student A and go 243 is 3 to the 5th power. And I'm going to have 5 minus 2 to the x here. But this student B goes, something's a little bit different. This right-hand side, I'm going to just go ahead and leave alone. And leave it alone as 3 to the 2x plus 4 power. Now, one of these students is right and one of these students is wrong. But they both have the general idea. They both realize you need to create common bases, which if you look, they both do. And they both realize we have to change 243 to 3 to the 5th power, which if you look at, they all did that, student A and student B. 243 is 3 to the 5th. There is nothing different on student A's side and student B's side. Their right side of that equation is completely 100% right. It's the left side that's different. Now, the reason why we create common bases is not to make new magical numbers out of nothing. It's to rewrite an equation, to rewrite an expression. So it's the exact same value, it's just easier to work with. And let's look at the left sides with that in mind. On the left side, I have a 3. I have a 3 to the 5th, and I have a 3. So what does that mean? On the left side, student A changed the value. It's not 3 to the 2x plus 4. They did 3 to the 5th to the 2x plus 4. That's wrong. They changed the left side of the equation. When you're dealing with creating common bases, you rewrite the base. You don't change the value. So student B is correct. Student A was wrong. And once we do that, I can go ba-bam, ba-bam, sweet, and solve. 2x plus 4 equals 25 minus 10x. I would add the 10x. I would subtract the 4 to get 21. And 21 divided by 12, they're both divisible by 3, 7/4. That's your answer. So that's the common base approach. Now, the logarithm approach. I'm going to show more work here. I'm not going to use the, definition. Hey! What power of blank gives me blank? No matter what, if you're going to use that definition or not, you need to isolate the base and the power. So I'm going to rewrite it so it's 12 to the x minus 8, and I would add the 130 to equal 300. So if you have a really good understanding of logarithms, you would go, hey, what power of 12 gives me x minus 8? And you would say, that would translate into log base 12 of 300 equals x minus 8, and get your answer fast. And that's an advanced understanding of that change of base process. But if you don't have that, that's fine. You have a general understanding, which is a very common, nothing wrong understanding of logarithms. You have to realize, ooh, I don't like exponents with variables, so I have to get the variable out of the exponent. So that means I'm going to take the log of both sides. And so I'm going to take the log of 12 to the x minus 8, check. And I'm going to take the log of 300, check. Well, why are we doing that? Because if I do that, I can take my exponent and bring it down. That's the power rule. And so I'm going to say, hey, x minus 8 times log of 12 equals log of 300. Well, I need to get the x minus 8 by itself, so I would divide, and I would get log of 300 divided by a log of 12. At that point, maybe you would put it in your calculator. You would get the decimal for it, but then you would not be done, because at that point, in order to be done, you would have to add 8. So let me just shrink this down, give myself some room. I don't have my calculator here, so I'm just going to write it as type this in your calculator. Log of 300 divided by log of 12. If you use the fraction feature in your calculator, you can do it all in one step. If you don't, type that in, hit enter, then do the plus 8, and get the magical decimal, which would be your answer for this one. So that is the next part in your test, is solving exponential equations. And there's two types of approaches. One that you can use a common base for, which you can still use logs, but man, logs would be complicated, honestly, on that one on the left side of the screen. Or you can use logarithms on this. So here we go. Ooh, simplify. So this is an addition. All right, so adding rational expressions, adding fractions, we need to make sure we can create common denominators. So I need common factors in the denominator. Good news. Ba-boom, ba-boom. First fraction, already factored, you're welcome. Bad news, second fraction, not already factored, you're welcome. But I can still factor it. What multiplies to 8 and adds to 9, x plus 8 and x plus 1. So let's just go ahead and do this. I'm going to change that, and I'm going to ignore this and change it to x plus 8 times x plus 1. All right, common denominator. Well, what do they have in common right now? They have in common an x plus 1. They both have it, so you know that's going to be in your denominator. What don't they have in common? Well, the fraction on the right side there has an x plus 8. But if I look further to the left, it doesn't have it. So I need to put an x plus 8 in that left fraction. That 1 over x plus 1 needs an x plus 8 in both the top and the bottom. So let's do it. Now, I'm just going to go ahead and use this instead of rewriting the whole problem. Because I already have an x plus 1 there. So I'm just going to do this. I'm going to put an x plus 8 over here. And I'm just going to do this. I'm going to extend the fraction bar, and I'm going to put an x plus 8 over here. And that's being multiplied. Good news. Multiply by 1 doesn't change anything, right? So what am I going to do? Well, here's what I want you to realize. When you have this part right here, this common denominator, you majority of the time have half your answer. Because that is your common denominator. There's a very good chance that is going to be the denominator of your answer. If after I distribute and combine like terms, there's a chance I might have to simplify. Who knows? That is just factoring cross out, not a big deal. But one of the reasons why it's nice to do this part first is you know half the answer. And it makes your next job easier. Notice I'm not going to write down the denominator. I'm just going to write down that I have 1 times x plus 8, which is x plus 8, minus, now hold on a second, let's just go ahead and write down the 2 possible answers that I get as a teacher in the numerator. The 2 answers I get as a teacher in the numerator for this type of problem is negative 2x plus 7, or I get students to say negative 2x plus 9. Well, those 2 answers, what do they have in common down below? They both have a negative 2x, right? So both students are doing the right thing with that first term. It's that second term. One student has a plus 7, one student has a plus 9. It's that second term where students make mistakes. And here's why. In this scenario, the real answer is negative 2x plus 7. The reason why is because what happens next when you are distributing and combining like terms. That minus sign is for I am subtracting that entire numerator. Well, I'm subtracting the entire numerator, an entire object. So I better put it in a parentheses. And then when you do that, if you think about it, you're subtracting 3x and you're subtracting a 1 if you're distributing it. Hence, negative 2x plus 7. So this student who would do negative 2x plus 9, notice they would forget to distribute to that positive 1. So be aware when it comes to subtraction what the main focus is for you to realize you're subtracting the numerator of that next expression, so it better be put in parentheses and distributed. All right, so the next one. Apply use substitution to factor and solve. Let's talk about this. Let's talk about some definitions, or primarily knowing what you're supposed to do when you read a problem. Forget definitions, directions. Apply use substitution to factor. So, a few things. Use substitution. Let's take care of that first. Well, I'm going to say u equals x minus 5. All right, let's take care of the next part of the directions. To factor. Well, let's set it up. I have still u squared minus 5u minus 14 equals 0. Let's factor. So let's do yellow for that one. U minus 7, u plus 2 equals 0. Let's finish off our directions and solve. Look at that. I can read the directions and know exactly what I'm supposed to do. So if I solve, I get u equals 7, and I get u equals negative 2. And you may go, I'm done because I solved. I get a variable equals a number. Sweet. Wrong. Because what are you solving for? In this problem, you have the variables as x's. X minus 5 squared plus, minus 5 times the quantity x minus 5, minus 14. This problem is really telling you to solve. You're right. You're solving. But what variable are you supposed to solve for? You're supposed to solve for x equals. You're not solving for u equals. We want to know, what does x equals? That's what the problem is asking us. Right here, you're telling me what u equals. Okay. Well, you already told me what u equals. So take the minute to go, you know what? I'm going to plug x minus 5 back in for u. And when that happens, I get x equals 12, and I get x equals 3. So keep that in mind. When I'm solving, you're not solving for u. Look at the variable that's in the original equation, and that's the variable you're solving for. All right, use substitution. Apply it, that was the green. Factor it, that was the yellow. Solve, ha, trick, you're not solving in the orange. You are solving and gets into the x equals 12 and x equals 3. Beware when it says solve what the last line should be. Your variable equals the variable of the original equation. All right, so the next one. State the asymptotes and check with your calculator. I'm not going to check with the calculator. I'm going to check with my mind. I encourage you to check with your calculator. I don't like the first one. I don't like that form. That's standard form, right? I have to look at two forms before I start solving. So I have, and I'm going to put it in parentheses, x plus 2 I like. X squared minus 4x minus 21. That's x minus 7. X plus 3. All right, those are the two forms. Those are my standard. Those are my factor form. What do I see? Nothing cancels out. Good news. That does not mean I have no whole. I have none. Beautiful. Vertical asymptotes. Vertical asymptotes are when you set the denominator equal to 0. So I have, don't forget, x equals 7, x equals negative 3. We are good. We have our vertical asymptotes. Horizontal versus slant. And I'm going to, you know what? Let's go ahead and do that. Let's put the word verse there. It's one or the other. And it's all based off of standard form now because nothing canceled. So I look at standard form. And I focus on just the first term. So bam, 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 all gone. X over x squared. You know what? Let's simplify that. 1 over x, right? Now, if I plug in real and behavior, that's what horizontal asymptotes are. If I plug in a really big number for x, 1 over infinity, 1 over infinity plus 1, you know, you just keep plugging in bigger and bigger and bigger numbers. If I take 1 and divide by bigger and bigger and bigger numbers, it's going to approach 0. So y equals 0 is my horizontal asymptote. So if I have 1 over x, if I simplify, or 5 over x, or whatever like that, if I have a larger degree in the denominator is getting bigger, faster than the numerator is. So it's going to approach 0. So y equals 0 is going to be your horizontal. And for consistency purposes, let's do none there. So there's the first scenario. Y equals 0 is when you have the largest degree in the denominator. Let's look at the next one. Oh, don't know about this one. Y, again, same thing. It's only giving me one form. I don't like that. I want to look at both forms. So I have to take the time to factor it. X plus 2, x minus 10. All right, so there's my two forms. Why do I do that? Because then I can look at the two different things. Vertical asymptotes. Wholes are best with factored form. I don't like that factored form right now because you notice they both have an x minus 10 in common. Wait a minute. If they both have an x minus 10 in common, I'm going to have a whole at x equals 10 because that's what canceled out. What I'm left with, by the way, if I just write it down here, I'm left with 1 over x plus 2. That's what I'm left with. Okay. But when I crossed out the common factor, the solution to that factor created a whole. So when I have x minus 10 in common, and that got crossed out, that's where I got the 10 from. It's a solution for it. But I still have this, don't I? I still have the x plus 2, which means I still have a vertical asymptote. If I set x plus 2 equals 0, I get x equals negative 2. All right, so you know what I'm going to do? I'm going to still put the verse there. V-S, verse. It's either horizontal or slant. Can't be both. Which form do I look at? I mean, look at this. I have standard form. I have factored form. Oh, I have another standard form. You know what I'm going to do? I'm going to look at the most simplified version. This is the most simplified version. So what's my horizontal asymptote here? I have a 1 on the top and x plus 2 on the bottom. So really that'd be like having a 1 over an x because all we care about is just the first term, right? That's what was the y equals 0. And there was no slant. So that's this situation. We had a whole in this case we had to keep an eye on. The third situation, x squared minus, plus 11x minus 18 over x plus 2. Still only one form, right? You have to do factor form. So let's see, what multiplies to 18? Well, 1 and 18 can't get 11. 2 and 9, ooh, 2 and 9. 2 and 9 can give me 11. But that can't be factored. Because if I do x plus 2, x plus 9, that'd be a positive 18. I have a negative 18 there. Well, okay, then do x minus 2, x minus 9, right? Well, that'd be a positive 18 still, and that'd be a negative 11. That doesn't work. Okay, if I want a negative 18, why don't I do negative 9 and 2? Because then I end up with negative 7x instead of 11. So the top can't be factored, people. So I'm going to leave it alone. Can't be factored, so that's the only form I can deal with. All right, so set the bottom equal to 0. X equals -2. I should have been a little more creative with the asymptotes. And since it can't be factored, hey, there's no hole. That was nice. Horizontal versus slant. Which one am I dealing with? Let's focus on it. Focus on the first terms. X squared on top, x on the bottom. That can be simplified, right? X over 1. When that happens, you have a slant. You do not have a horizontal. Your numerator is increasing faster. It's going to infinity faster than the denominator is. So you think about a line's approaching infinity forever, forever, forever. So it's going to be a slant asymptote. How do I find a slant asymptote? The magical world of division. So I'm going to take x plus 2 and I'm going to divide it into x squared plus 11x minus 18. So if I do that, I'm going to end up with an x here. X times 2 is a 2x. So let me give myself a little bit of a square. All right, but I don't want 2x, right? I want 11x. So I'm going to need a 9x here. So that's a plus 9. It's a positive 18. Good news is we don't need to worry about a remainder. I have just this, and it is a slant. So it's going to be an equation, y equals x plus 9. So there it is. There are the three situations that we were looking at. What happens, by the way, we looked at 1. What happens when you're dealing with this? What if I have like 3x plus 2 over 2x minus 1, and I want to know what's my horizontal or slant asymptote? I'll look at the first terms, right? And look at this. The x's would cancel. Well, that 3/2 would be y equals 3/2, my horizontal asymptote. So there we go. So that's the other situation that could have happened. Write the equation of polynomial function with the following characteristics. All right, what's the characteristics? Cross is at x equals 5. All right, so hold on a second. Cross is at x equals 5. Let's write that down. X equals 5. That was hard. Cross is at x equals 1. All right, hold on. X equals 1. Hey, these are solutions. It bounces. That's weird. Bounces. Double root at x equals -2. What does that mean? I'm going to have x equals -2 twice. What does that mean as a factor if I have x equals -2 twice? Hold on a second. That means I have an x minus 5. I have an x minus 1. I have an x minus 2. Sorry, x minus a -2, which would be an x plus 2 twice. That's not your function. That's the beginning steps of your function, because it says it passes through the point 3, -40. So I have a y equals, and I want to know what is this value of a. And here's what you realize, and I'm going to do this right now. I know, let's call it 3/4 of my answer. I know in my answer, my final answer, I'm going to have a y equals something x minus 5, x minus 1, x plus 2 squared. Let's go put it on the bottom. I give myself a little more room here. Boom, boom, boom. Shrink it there. That's not, all I need is a. I know majority of my answer. So let's just go ahead and find it. Let's plug it in. I'm going to have a -40 is a y. Man, it's a lot of work to plug in 3. So why don't I just do some of the math right below it. I'm going to have 3 minus 5. You know, that's -2. I'm going to have 3 minus 1. That's +2. I'm going to have 3 plus 2. That's 5 squared. That's 25. -2, 2, and 25 is going to be -100. So this is going to be -100, and I still have that a. If I do that, I'm going to get, let's see, I have 4 over 10, because I can simplify one of the zeros. That's good news. And negative divided by negative is positive. 4/10 is the same as 2/5. So that is my answer. Notice all I did was put my a down. I mean, when I had this part right here, I knew majority of my answer. My job was to find a. It's kind of like adding, subtracting rationals, right? When I've had my common denominator, I knew half my answer. I just had to distribute and combine like terms. It's the same idea here. Ooh, last one. I put parentheses in there to make it easier. Solving a logarithmic equation. Let's kind of talk about this for a second. What do I have? can't solve, right? I mean, at this point, I can't just go, hey, they all have logs, magic, and cross. No, it doesn't work that way. There are only two ways to solve logarithmic equations. They have to look like this. And let's do yellow and green. They have to either be a log of something equals the log of something. No plus signs, no minus signs, no exponents or coefficients. You just, bam, you can cross out the logs in that case. So in this case, you can cross out the logs. Or you can have log of some base equals a number. So log of some base equals a number. In that case, you have to go to exponential form. So knowing that these are the two ways to solve logarithmic equations, only ways we can solve logarithmic equations, only format structures you could use, I need to know what this problem is dealing with. Which one of those two? Well, seeing it has log on the left side and logs on the right side, I'm leaning towards this, which means I have to merge my logs together. This is like the stuff your brain needs to start thinking when you're going through this. Well, how do I merge logs together? Well, I'm subtracting logs. Logs are powers, right? Well, when you subtract powers, when you subtract exponents, you do that when you are dividing. So when I merge this, I'm going to merge it by saying I have log base 9 of x plus 6 over x equals log base 9 of 2. Wait a minute. Log equals log. Ba-boom, ba-boom, cancels. And so I have x plus 6 over x equals 2. I'm going to come over here and I get 2x equals x plus 6. X equals 3. And there we are. So that is the problems that we're dealing with. These are the main ideas that you're looking at. These 9 concepts in the video. Hopefully this clarified some of the things. Hopefully help you feel better prepared for the Chapter 6 test.